Okay, in this video, we are talking about the nth root and rational index. Let's do some recall. If there's an equation x to the power n equals k, then we'll write x equals to k to the power 1 over n. So let's see some example. If x to the power 3 equals 5, then we can write down the solution of x equals to 5 to the power 1 over 3. But if we consider the value of x in the perspective of root, we can write in that way also. If x to the power 3 equals 5, then x can be written as 5 and take the cube root. Okay? Therefore, we can see that 5 and then take the cube root equals to 5 to the power 1 over 3. And that's the way we could introduce the nth root and the rational index. In general, if there's an equation x to the power n equals k, we can also write in that way. X could be written as k and then take the nth root. And how do we read this? We read as x is the nth root of k. Nth root of k. That means these two expressions are equal. Okay? But of course, you should keep in mind that when you take the nth root of k, that means these whole expressions inside the root would whole take the power 1 over n. But in here, it just only have one term here, so we usually skip the bracket. But inside here, if there's a b, okay, here, then when we change it to the power, we will write in this way: the a times b bracket 1 over n. Okay, so there's some remarks. If we consider the k to the power 1 over 2, we usually just write down square root k. We would not write 2 on the top left hand corner. Okay, just square root k. That means k to the power 1 over 2. Second, if there's a power inside the root sign, that means we multiply this one to the numerator of the index. So k to the power n and then take the nth root equals to k to the power m over n. Of course, you can take out the power m and then take the nth root first. To simply say, if you want to take the nth root, then the power will be 1 over n. So let's see some examples. So you need to simplify these two expressions. 1, a times square root a to the power 5, b, cube root of b to the power 4 times b squared. So let's see how do we do this. In part 1, a times square root of a to the power 5. The first a, that is a to the power 1. In the middle, that means multiply. The square root, that means power 1 over 2. We change all the root sign, becomes the index. Okay, becomes index. So this square root becomes the index 1 over 2. So that is a to the power 5 bracket to the power 1 over 2. And these two numbers should multiply together, becomes a to the power 5 over 2. So a to the power 1 times a to the power 5 over 2. The base are the same. When you do the multiplication, then you need to add the index up. So that is a to the power 7 over 2. So part 2. When you consider these expressions, cube root of b to the power 4 times b squared, first of all, change all the root sign, becomes index. So that is b to the power 4 bracket power 1 over 3 and then times b squared. And next step becomes b to the power 4 over 3 times b squared. Again, the base are the same. When you are doing multiplication, you add the index up. So you get the answer, that is b to the power 10 over 3. Of course, in exam, you can present in this way. There's a shortcut. Some simplification steps could be skipped. Okay. The key point is you need to show a step that's changed the root sign become the index. Okay. Next, simplify these two expressions. Then what can we do? For part 1, 27 times m to the power 12, and I take the whole cube root. So you need to add a bracket to it, that is become 27 times m to the power 12, and then bracket 1 over 3. For this index 1 over 3, it can be distributed to 27 and then m12 because there is only one term inside the bracket. So simplify this, you get 3 times m to the power 4. For part 2, n to the power 24 over 64 to the 6th root. 6th root. That means n to the power 24 over 64 and then whole bracket to the power 1 over 6. For this index 1 over 6, it can be given to the both numerator and denominator. So you can get n to the power 4, that's 24 divided by 6. And denominator, that is 2 only. Because 64 and then take to the power 1 over 6, you just get 2. In the exam, you can just write down these two steps. Okay? You can just simplify the expression. One step like this is okay. Okay, this question, you need to simplify these expressions and then give your answer with positive index. So, x to the, and take the 5th root, okay? 5th root of x over square root of x and then bracket to the power 4. You need to simplify this. So let's see what we can do. First of all, we change all the root sign into the index form. So that is x to the power 1 over 5 over x to the power 1 over 2. And a whole bracket to the power 4. And you should simplify something inside the bracket first. As you can see, the base of these two are the same. So when you are doing division, then you just take the subtraction of the index. That will become negative 3 over 10. And then take to the power 4. Simplify this, that is negative 3 over 10 times 4. So you get x to the power negative 6 over 5. But if you want to change the negative index to positive index, you need to put it in the denominator from numerator. So the final answer will be 1 over 6 to the power 6 over 5. Okay, this one, you need to simplify this one and give your answer with positive indices. So let's see what we can do. As you can see that there's a 4th root and then n cube. So we need to simplify the root sign and then change it into index. So that is n to the power 3 and then 1 over 4. So finally, that's n to the power 3 over 4. That's a 4th root, so the index will be 1 over 4. And multiply to this 3, so the index will become 3 over 4. And then m to the power negative 2, just keep it. Denominator, n, that is n to the power 1. And usually we will omit this one, we will not write this. Square root m, that is m to the power 1 over 2. Now in the numerator, there's a whole bracket to the power 3. We multiply 3 inside the bracket, that's become n to the power 9 over 4 times n m to the power negative 2 over 3. So look at the base with n doing subtraction when you are doing division. Okay, what does that mean? When you are doing division of the whole expressions, then you need to subtract the index. So 9 over 4 minus 1, that is 5 over 4. So that is n to the power 5 over 4. And consider m to the power 2 over negative 2 over 3 divided by m to the power 1 over 2. Again, take the subtraction of the index. That's become m to the power negative 7 over 6. But this is not the final answer. You need to change the negative index to the positive index. So you need to put this one in the denominator. That's become n to the power 5 over 4 over m to the power 7 over 6. That's the final answer. Okay, and simplify these two expressions. It look a bit clumsy and difficult. The key point is we need to start simplifying such kind of the expressions from inside to outside. So let's look at the first one. So there's a square root, and then inside there's x cubed times square root x again. So we start simplify from inside. We change square root x become x to the power 1 over 2. So that is x cubed times x to the power 1 over 2. So add the index up, that's become x to the power 7 over 2. Now look at the square root outside. We change this square root into index, that's 1 over 2. So x to the power 7 over 2, and then to the power 1 over 2 again. Finally, that is multiplying these two index together, you get x to the power 7 over 4. And part 2, again, you start simplifying something inside here. So cube root of y, that is y to the power 1 over 3. Multiply this y, that's become y to the power 4 over 3. But you need to consider this square root sign again. So y to the power 4 over 3, and then bracket to the power 1 over 2 again. So you get final answer y to the power 2 over 3.